The James Webb Telescope is one of the largest instruments in the history of astronomy, and the data it provides is spectacular. Its images and information can give us a deeper understanding not only of other celestial bodies but also of the early universe. It can assist in studies, including Hawking's theory, which presupposes the existence of the multiverse. The James Webb is capable of detecting infrared radiation from space at a distance of 13.6 billion light-years. Impressive, isn't it? To give you an idea, science believes that the Big Bang and the beginning of the universe occurred approximately 13.8 billion years ago. In other words, the James Webb can observe regions that are practically at the beginning of the universe. In its early stages, scientists intend to use it to study how galaxies and planetary systems formed and evolved. Additionally, it is possible to observe black holes, supernovae, and other distant objects. Thomas Zurbuchen, NASA's Associate Administrator for Science, even said that astronomers will find many surprises and mysteries, ones we can currently only dream of. From a space base in French Guiana, the telescope was launched aboard a rocket called Ariane. Its primary mirror has a diameter of 6.5 meters, making it the largest ever launched into space to date. Therefore, it had to be folded for transport, and its unfolding was gradual. The final configuration was completed when it reached a distance of 1.5 million kilometers from Earth, assuming a shape similar to a honeycomb. The mirrors are composed of 18 hexagons. While the Hubble telescope orbits the Earth, the James Webb orbits the Sun. When it reaches its final position, it will be located at the second Lagrange point, known as L2. These points are gravitational intersections where the gravitational forces of the Sun and Earth balance each other, allowing an object to remain relatively stationary with little effort. That is why the Webb, also known as JWST, will stay in this position, aligned with Earth as it moves around the Sun. The sun shield of the telescope, in addition to blocking the light and heat from the Sun and Earth, also enables the maintenance of its operation. $10 billion were invested in the James Webb project, but there are still many discoveries to be made as it can remain in orbit for up to 10 years. We are certain of these discoveries because some of them are already being made at this moment. The James Webb Space Telescope has detected what appear to be 4 enormous ancient galaxies that could challenge current theories of universe formation. The farthest one, named Glass Z13, is about 13.5 billion years old. Its light is the farthest observed to date. But how do we know it's the oldest? It's simple, the distance and velocity are calculated, determining the arrival time of light to the telescope, which means the light took 13.5 billion years to reach us. Therefore, we are seeing the state of the galaxy almost 13.5 billion years ago, practically at the beginning of the universe. The Glass Z13 is only 300 million years younger than that galaxy, making our universe even more fascinating, isn't it? The James Webb transports us to the past and allows us to visualize how galaxies were in the early stages of our universe. Another detail captured by this telescope is the fact that Glass Z13 is only 1,600 light-years in diameter. In comparison, our Milky Way is about 100,000 light-years across. With all this technological power, the telescope will enable us to uncover hidden secrets. If we could observe the earliest events of our existence, according to physicist Stephen Hawking's theories, we could not only witness the creation of our universe but also of several others. The multiverse theory, formulated by Stephen Hawking, suggests that the discoveries made by the James Webb could assist in future studies. This theory would be a solution to the cosmic enigma, presenting the idea that parallel universes may exist. In the 1980s, Hawking, in collaboration with physicist James Houston, developed a new idea about the beginning of the universe. The proposal of the two researchers employed a different approach from the traditional one. They used concepts from quantum mechanics to explain how the universe could have emerged from nothing. Developing this idea, they considered the following hypothesis: the Big Bang did not create just one universe but countless others. Some of these universes could be similar to ours, with planets resembling Earth and societies similar to ours. Other universes could have minor differences, such as one in which dinosaurs did not go extinct or where humans are not the dominant species. And there could still be universes completely different from ours, perhaps without Earth, without stars, or with different laws of physics. Although it may seem strange, these theories have equations that make these scenarios somewhat plausible. However, a question was raised and posed problems for the researchers. If there are various types of universes, the theory cannot predict which type we find ourselves in. The university professor and his research colleague were dissatisfied with this uncertainty and did not wish to give up. They did not want to admit that the multiverse arose randomly and that they could not move beyond that point. To resolve this impasse, they embarked on a 20-year research project that used new mathematical techniques to study string theory, a branch of physics. According to these studies, universes with masses lighter than ours can exist. This means that our universe is typical, and the observations made within it can help us understand how the others came into being. According to the researchers, the laws of physics did not always exist. They formed after the Big Bang when the universe expanded and cooled. The types of universes that can exist depend on the physical conditions of the Big Bang, and by studying them, it will be possible to better understand the origin of our physical theories, how they arise, and whether they are unique. With this information, it would be possible to detect the presence of other universes by studying microwave radiation and other cosmic evidence. However, the aforementioned researcher stated that he believes traveling between universes is not possible, which has generated controversies among scientists. Traveling from one universe to another is a theory that the James Webb Telescope can help the industry with. It involves dark matter, which accounts for over 80% of all matter in the universe. It generates extra gravity and does not interact with ordinary matter. We only know of its existence because of its gravitational effects on celestial bodies such as stars and galaxies. In 1970, Stephen Hawking suggested that dark matter could be composed of black holes formed in the early moments of the Big Bang or particles of matter that reached the necessary densities for its formation. What happened to these particles even before the emergence of stars is something that the James Webb Telescope could help study. Currently, researchers from the United States and the European Space Agency are conducting a study based on the telescope's data. The objective is to trace the origin of very ancient black holes and relate them to the detectable mass of dark matter present in the known part of the universe. The expectation is that the James Webb Telescope will significantly contribute to science, assisting in the research and discovery of the mysteries of those distant times, the beginning of physical existence. If it can indeed visualize objects at a distance of 13.6 billion light-years, as expected, the telescope could contribute to the multiverse theory in a way that is not refuted by Webb. However, it is possible that another even more advanced large telescope will be launched by humanity, such as the Giant Magellan Telescope, GMT. The GMT will have a mirror with a light collecting area equivalent to 368 square meters, being 4 times more powerful than the James Webb and 200 times more powerful than any other research telescope. The prediction is that the GMT will be launched in approximately 10 years. We can be sure that the coming years will bring incredible discoveries for astronomy. And what about you? Do you believe in the existence of other universes? Leave your comment and don't forget to share this video on your social networks.